All right, welcome back. Today we're going to be looking at the second part of section 9.3, which is solving quadratic equations using square roots. Your homework looked really good yesterday. A couple of comments on the problems. Just make sure that you are including both the positive and the negative value in your answer. So when you are taking the square root of a number, again, there's two values that when you square it, you would get, for instance, 25. So 5 squared is 25, negative 5 squared is also 25. So you're going to have two different answers. And then again, for square roots of negatives, we can't do that, so we write no real solution. I know some of you know that that's an imaginary number and you know how to write that. So if you want to write it that way, go for it. If not, you can just write no real solution. But yeah, overall, your homework looked great. All right, looking at today's, we're going to be solving equations. They'll get a tiny bit more complicated. So again, in solving these equations, our goal is to isolate the value that's being squared. So for example, in A, we have 4x squared plus 3 equals 23. So we want to isolate that x squared. So we're going to start by subtracting 3. So we would have 4x squared equals 20. We want to divide both sides by 4, and we're left with x squared equals 5. Now, when we go to take the square root of both sides, we'll be left with x. 5 we don't have a square root for. It's not a whole number, unlike the other problems we did earlier. So we can leave our answer as plus or minus root 5. The instructions here do say round your solution in the nearest hundredth. So go ahead, take a calculator, take the square root of 5, which is 2.24. We can just write that as plus or minus 2.24. So in your homework, please include both of those answers. If it says to round it to the nearest hundredth, go ahead and give this answer as well. Otherwise, you can just leave it as positive or negative root 5. All right, in B, we have 2x squared plus 7 equals 9. So we would add 7 to both sides. That gives us 2x squared equals 15. Divide both sides by 2. We get x squared equals 15 halves. Again, when we go to take the square root, we don't have a whole number that's a square root of 15 or 2. So we're going to leave our answer as just plus or minus root 15 over 2. And then again, take your calculator, take the square root of 15 halves, which is 2.74. Okay, and again, just leave both of those answers as part of your answer on your homework or whatever assignment you're doing. All right, last one on C, we're going to subtract 1 from both sides. That gives us 6g squared equals 18. Divide both sides by 6. We get g squared equals 3. Again, when we go to take the square root of both sides, we don't have a perfect root of 3, so we can just leave it as plus or minus root 3. Grab your calculator and take the square root of 3, which would round to 1.73. So we would have plus or minus 1.73. All right, in the next set of examples, we're going to be doing the same type of thing, solving the equation, rounding the solution to the nearest hundredth. So in these cases, we have a quantity being squared. So in A, we have 5 times the quantity x plus 1 squared equals 30. So our goal is to get that quantity that's being squared isolated. Okay, so we are going to divide both sides by 5. That'll leave us with x plus 1 quantity squared equals 6. Now we need to undo the squaring, so we are going to take the square root of both sides. The square root is going to undo that squared, so that'll leave us with just x plus 1, and then here we would have plus or minus root 6. Again, 6 is not something we have a perfect square root for, so we would just leave it as root 6. We still need to get x by itself, so since we have x plus 1, we're going to subtract 1 from both sides. So our answer would be x equals, and then here we have this quantity. So it's usually written with the number first, so negative 1 plus or minus root 6. So you're literally going to write negative 1 plus or minus root 6. Okay, so please give that answer. That would be your exact answer, or it might be your answer in radical form would be the language it would use. And then rounding to the nearest hundredth, you're going to type this in twice on your calculator. So you're going to type in negative 1 plus root 6, and you'll get one answer, 1.45. And then you're going to type in negative 1 minus root 6, and you'll get your second answer of negative 3.45. Okay, so again, give me the exact answer kind of showing your work that you had done, and then go ahead and round the two answers to the nearest hundredth if that's what the homework problems are asking you to do. All right, for B, we have a similar setup. We have 3 times the quantity m minus 4 squared equals 12. So we're going to start by dividing both sides by 3. That'll give us m minus 4 quantity squared equals 4. When we go to take the square root of both sides, we do know the square root of 4. So on the right-hand side, we would get plus or minus 2. On the left-hand side, again, that square root's going to undo the squaring, leaving us with m minus 4. We need to get m by itself, so we're going to add 4 to both sides. That'll give us m equals 4 plus or minus 2. Well, this we can figure out ourselves. 4 plus 2 gives us 6. 4 minus 2 gives us 2. So we get 2 answers, 6 and 2. All right, for C, we're going to again start by dividing both sides by 4. So we isolate that value that's being squared. That gives us a minus 3 squared equals 8. We need to take the square root of both sides. So that leaves us with just a minus 3 on the left-hand side, plus or minus root 8 on the right-hand side. We want to isolate the a, so we need to add 3 to both sides. So we would have 3 plus or minus root 8. And then again, go ahead and take your calculator and type in 3 plus root 8. That'll give you 5.83. Then to 3 minus root 8, and that'll get you 0.17. So we have our answers. Again, this is our exact answer, and then our answer rounded to the nearest hundredth. Okay, the last set of examples are really specifically set up in a certain way. So if we can recall when factoring, we can factor this left-hand side. This would factor into x plus 3 quantity squared. Then we'd have equals 16. So remember when we have x plus 3 times itself, when we do our double distributing, we would get x squared plus 6x plus 9. Okay, so that factors out. And then because it's in this format, we can take the square root of both sides. So we would have x plus 3 equals plus or minus 4. Take away 3 from both sides. We would have negative 3 plus or minus 4. So this one we can just do. Negative 3 plus 4 is 1. Negative 3 minus 4 is negative 7. Okay. For B, again, this is going to factor perfectly into the quantity x minus 2 squared. We can take the square root of both sides. That gives us x minus 2 equals plus or minus 10. Add 2 to both sides. We would get 2 plus or minus 10. And again, this is one we can just do. 2 plus 10 is 12. 2 minus 10 is negative 8. And those are our 2 exact answers. For C, this would factor into x minus 5 quantity squared. We can take the square root of both sides. Get plus or minus 11. Add 5 to both sides. We'd have x equals 5 plus or minus 11. 5 plus 11 gives us 16. 5 minus 11 gives us negative 6. All right, for D, we'll notice we have a coefficient of 2, and all of these numbers are divisible by 2, so we can divide both the left and the right-hand side by 2. That leaves us with x squared minus 14x plus 49 equals 36. And this factors perfectly into x minus 7 quantity squared equals 36. We can take the square root of both sides. So we'd have x minus 7 equals plus or minus 6. Add 7 to both sides. And then 7 plus 6 gives us 13. 7 minus 6 gives us negative 1. Oops, sorry, positive 1. And those are our 2 exact answers. Okay, so for example 4, these are really specific problems where this left-hand side factors perfectly into a quantity squared, and the right-hand side's a perfect square. So that won't always be the case, but this is just another set of examples showing you how this could work. But most of the ones you'll already have that quantity squared, or you'll have a single value squared.